Now we will differentiate the 9 parametric equations. X is equal to a secant theta, y is equal to b tan theta. So let us write the first step. Given parametric equations. So given parametric equations, x is equal to a secant theta, y is equal to b tan theta. So here theta is the parameter. So the function x is with respect to theta and this function is dependent on theta. But we want y dependent on x. So for that dy by d, you have to write theta divided by dx by d theta. So this is equation 1, and we know that denominator should not be equal to 0. So we want this dy by d theta and dx by d theta. For that we have to differentiate. So first we will write x is equal to a secant theta. We will differentiate both sides with respect to theta. So we have dx by d theta is equal to d by d theta a into secant theta. This implies dx by d theta is equal to, so we have derivative of constant into function. So when we have in that form derivative of constant into function, we'll write constant into derivative of the function. So constant into derivative of the function. So this implies dx by d theta is equal to a into derivative of secant theta. So derivative of secant x is secant x into tan x. So here we will write a secant theta into tan theta. So this is equation 2. Now we will differentiate y is equal to b tan theta. So differentiate both sides with respect to theta. So we have dy by d theta is equal to d by d theta into b tan theta. So this implies dy by d theta is equal to derivative of constant into function. So we will write constant into derivative of the function. So this implies dy by d theta is equal to b into, so derivative of tan x is secant square x. So derivative of tan theta is secant square theta. So we got the third differential equation. So we have to substitute in 1. Now putting 2 and 3 in 1, dy by dx is equal to, first we have to write this dy by d theta. So we will write b secant square theta divided by a secant theta into tan theta. So this implies dy by dx is equal to, so here we will write b by a, and secant square theta will get cancelled. So 1 will remain secant theta. Then we have 1 by tan theta, right? So now this implies dy by dx is equal to b by a. Why we can simplify further? Because we know secant has cosine angle and even tan has cosine angle, right? So this we can write 1 by cos theta into 1 by tan theta can be written as sin theta by cos theta. Now this implies dy by dx is equal to b by a 1 by cos theta. So how we can simplify this complex fraction? When we have 1 divided by a by b, we will write this as b by a. Both are same. So now this implies, so here we will write 1 by cos theta, then here we will get cos theta by sin theta, right? So 1 divided by a by b, so we will get b by a. Now this implies dy by dx is equal to b by a. Cos theta by cos theta is 1, so you will get 1 by sin theta. So therefore dy by dx is equal to b by a, and 1 by sin theta is cosecant theta, right? So this is the derivative of the parametric equations. Hence we completed the 9th one. Continuity and differentiability exercise 5.6. We have completed 9 questions. Now we'll find the derivative for the 10th parametric equations. X is equal to a cos theta plus theta sin theta. Y is equal to a into sin theta minus theta cos theta. So let us write the first step. Given parametric equations, x is equal to a into cos theta plus theta sin theta, y is equal to a into sin theta minus theta cos theta. So here theta is the parameter, right? So the function x is dependent on theta, and even y is also dependent on theta, but we have to find dy by dx, y with respect to x. So we know that this is dy by d theta divided by dx by d theta. So this is 1, and here we will write dx by d theta is not equal to 0. Denominator is not equal to 0. Now we will find the numerator and denominator. So first let us find denominator. So we will write x is equal to a into cos theta plus theta sin theta. So we want dx by d theta, so we have to differentiate. Both sides with respect to theta. We have dx by d theta is equal to d by d theta into a into cos theta plus theta sin theta. Now this implies dx by d theta is equal to derivative of constant into function. So how do we differentiate when we have derivative of constant into function? We will write constant outside and we will differentiate the function, right? Constant into derivative of the function. Now this implies dx by d theta is equal to a into, now how do we differentiate function plus function? We will apply u plus v rule, derivative of u plus v rule. So here we will get d by d theta into cos theta plus d by d theta into theta sin theta. You have to put the brackets because a is multiplied to both the terms here. Now dx by d theta is equal to a into derivative of cos theta is minus sin theta plus d by d theta into function, right? So even this is a function and this is also a function. So how we will differentiate function into function? We'll apply product rule. So we get uv rule, uv theta derivative of sin theta, then plus sin theta and derivative of theta. Now this implies dx by d theta is equal to a into minus sin theta plus theta into derivative of sin theta is cos theta plus sin theta. So derivative of theta is 1. So how you got this as 1? By applying x power n rule, d by dx of x power n. So if you apply this rule, which is n into x power n minus 1. So if you apply this, you will get, so here theta to the power 1. So you apply and check, you will get the derivative of theta will be 1. Now this implies dx by d theta is equal to a into minus sin theta plus sin theta will get cancelled. So you will get a into theta cos theta. So now this is equation, differential equation 2. Now we will find dy by d theta. For that we will write the equation y is equal to a into sin theta minus theta cos theta. Since we want dy by d theta, we have to differentiate both sides with respect to theta. We have dy by d theta is equal to d by d theta a into sin theta minus theta into cos theta. So again here we have derivative of constant into function, derivative of constant into function. So we will write constant into derivative of the function. Now this implies dy by d theta is equal to a into, now how do we differentiate when we have function minus function? Derivative of function minus function, we will apply d by dx of u minus v rule. So we will write here d by d theta of sin theta minus d by d theta theta cos theta. Now this implies dy by d theta is equal to a into derivative of sin theta is cos theta minus derivative of theta into cos theta. So here we have to apply product rule, right? uv rule. So this is u and this is v. So uv rule, but we have to be careful because here we have minus sign. Okay, so we'll put the brackets and we will write theta into d by d theta of cos theta plus cos theta into d by d theta of theta. Now this implies dy by d theta is equal to a into cos theta minus theta into derivative of cos theta is minus sin theta plus cos theta, and derivative of theta with respect to theta will be 1. Now this implies dy by d theta is equal to a into cos theta, minus times minus is plus, theta sin theta, minus into plus is minus cos theta. So now if you observe, plus cos theta minus cos theta will neutralize, so therefore you will get dy by d theta is equal to a into theta sin theta. So we got dy by d theta, which is 3. So what we want now, finally we want dy by dx. So first we will substitute equation 3, which is dy by d theta, then dx by d theta. Now this will be a into theta sin theta divided by, so dx by d theta was a into theta cos theta. So if you observe here, a by a is 1, theta by theta is 1. So we will write sin theta by cos theta as the remaining. And we know this which trig function here, this is tan theta. So therefore dy by dx is equal to tan theta. So this is the derivative of the 10th function.